So we'll be recording this session, okay, and for others to join, for others to refer, and you can refer this as well later as well. Okay, so when it comes to Kubernetes, right? Okay, so before we get started, let me introduce myself first, guys. This is Roshan. I have around 16 years of experience into IT. I'm mostly currently working as a principal SRE with one of the retail giants. I started my career into Java development. I was into Java development and Python development and into automation as well, using Terraform, Ansible, Shell scripting, PL SQL, Selenium, all sorts of automation, basically using Python scripting. So currently working as a principal SRE, guys. Okay. I've been into performance engineering from quite some time. Around 6 years of my career, I was into performance engineering, mostly into Java performance engineering, troubleshooting Java application, optimizing Java code, and all those things. Okay. So today's agenda is to talk about Kubernetes, right? So how Kubernetes is reliable. So when it comes to reliability, right? So first of all, we need to understand what is reliability, right? And then we need to understand the focus, the agenda for today's of this workshop is to understand how Kubernetes helps in making your production system reliable, right? So before we get started on that part, we need to understand first what is reliability mean. Anyone can help me understand? Can anyone just would like to share your point of view? What do we mean by reliability? If you have an understanding of it, anyone? Before I get started.
System is always available.
Okay, so see, high availability is one thing, right? So there are a lot of we use a lot of words, or I would say terminology interchangeably. Okay, so the words are high availability, fault tolerance, reliability. We are using these technologies or these terminologies quite interchangeably, but there is a specific meaning of highly reliable application, right? When it's the high availability, that HA, right? That is HA that we're talking about. Let's not confuse HA with reliability. Yes, both are linked. It's not like both are totally separate thing, right? It's not that way, right? But reliability has a separate meaning. Okay, let me talk about it. Okay, anyone else?
Hello.
Yeah, go ahead.
You just joined. Could you just brief about that one?
No, the agenda for today's discussion is to talk about how Kubernetes implementation is going to help you make your production system highly reliable. That's what the agenda for today's discussion is, right? So that's what we just started on, nothing else. We have not started. So I just asked this question with everyone, right? Anyone can pitch in an answer. Like, what do we mean by reliability? When you say reliability, what do we exactly mean, right? See, reliability or resilience, right? It's the same thing, right? So basically,
So, sir, I would like to answer. I believe the answer should be with how the system is dependable. Means how much system is dependable to the users.
Dependable. So, what do we mean by dependable? Can you?
Maybe how stable the system is stable.
Krishna, you're breaking up. Okay, let me put things into perspective. Okay, so there are some technical words that we use nowadays, right? So let me see, these are the words that we use nowadays. High availability. Okay, let me put this into perspective and then we'll talk about it. So there are the words that we use. High availability, HA, right? We use this word, and then we use the word fault tolerance. And then we use the word reliability. So these words have different meaning. Exactly different meaning. It all boils down to the same thing, that all these terminology, right, boils down to the one thing, that at the end I don't want to have downtime, and I don't want to degrade my performance. Even if any system failure has happened, all this term, if I sum it up, right, that boils down to that particular statement, that I want my application to be highly available. I don't want downtime. That's very unrealistic. Even Google has a downtime. few minutes in many years, right? We also have a downtime. We talk about 99.999% availability, 11 nines or 9 nines, we talk about that. Even very unrealistic, it's not practical to have zero downtime. We can be very close to zero downtime, that is possible, but these words, high availability, fault tolerance, and reliability, have a separate meaning. So when I say reliability, right, basically I'm talking about resilience, right? So how soon my system can recover? See, failures are bound to happen. Failure will happen. Either one node will go down, one pod would go down, some or the other issue would happen, right? But how soon your system recovers, your application recovers, and what was the performance degradation, whether you degraded on the performance, that will depend how good your system is reliable, whether your system is reliable or not. That is what we call it, reliability. So in simple terms, it's recoverability, as I'm showing you in this particular PPT, right? Reliability, simple term, recoverability. How soon capacity of a system to recover from infrastructure or service disruptions. Failure will happen, but how quickly you regain functionality. That is what the reliability mean. Okay. Then we have term fault tolerance or high availability. So when I say high availability, right, even if failure is happening, my system is available. So how is that possible, right? So there are multiple ways to achieve that, right? Multiple ways to achieve that. Let's say high availability. I would tell you one example on one thing. When you design any particular application, let's say in cloud, I hope some of you would be knowing about the cloud. We have a concept of region, and one region has multiple availability zones, right? Let's say I have this region here, any region, and let's say I have multiple availability zone, AZ1, AZ2, AZ3. How can be highly available? So the idea is to not to have a single point of failure. We call it not to have a single SPOF, single point of failure. So how can we don't have a single, how can we avoid single point of failure? If we have multiple nodes in one AZ, let's say I have 2 nodes per AZ, right? So basically I'm talking about even if one node goes down, I have other nodes which can service the request. One of the ways to be highly available. One of the ways. That's why in AWS we have a concept of region and availability zones. The way, not just in AWS, in Azure or GCP, same thing. We have a concept of region, and in that region we have multiple availability zones. We don't have one availability zone. We never have one availability zone. That is one of the regions. And not just single AG deployment, I can go with multi-AG deployment. Multi-AG deployment, if I go, so even if my entire AZ goes down for any region, disaster recovery or natural disaster happened, so I have other regions to take care of the service requests, and I can load balance all my servers across AZ1 and AZ2. So that's one of the ways to be highly available. Okay, coming to the high reliability we talked about. So how can we achieve reliability? How can we achieve reliability? Okay, so the first question that I asked you, right? Reliability. What do we mean by reliability? See, in AWS we have recover from failure. So let's say in Kubernetes we have something called replica sets. Failure will happen. Pods may go down. But there is a concept in Kubernetes called replica set. One of the features of Kubernetes, we have a concept of fault tolerance. We have a concept of replica set in Kubernetes. That makes sure that even if, let's say, in the replica set, if I mention that for one microservice, let's say when I'm defining, I mentioned that I need to have 4 pods or 5 pods of this microservices, whatever, M1, running all the time. It is a replica set would make sure that 5 pods are always running. Even if some issues, let's say out of the memory issue happened or some issue, out of memory issue or thread got hung or something, for any XYZ reason, for any reason, if one pod is not become unresponsive, it will create a new pod. Pod means basically it will have the containers, right? We have a concept of microservices and we deploy microservices on the containers. And that's what we talk in, we can create containers using Docker, and we use container engine concept in Kubernetes, right? Same thing. So that's what reliability means. And these are the features, right? And one more terminology that I use was the fault tolerance. I use one more technology word called fault tolerance. What is this? I don't want to degrade on the performance. See, failure will happen. See, all these talks, reliability, high availability, fault tolerance, in any scenario, failure is happening. One of the component is getting failed. But I don't want to compromise on the availability. I don't want to compromise on the performance. And on reliability or high availability, I don't want to compromise. Failure will happen. And that's why we do chaos testing in production. We purposefully bring one node down and we see the impact. What does it impact? That's what the chaos engineering is all about, right? All of a sudden, we make something fail in production. We just bring one node down, two nodes down, and we understand how soon your system recovers. We have a concept of auto scaling. In the cloud, we have concept of auto scaling. Auto scaling, what it promises that, let's say you have currently 4 servers running, let's say. We have 4 servers running, and let's say these 4 servers are able to handle, let's say 500 users with good response time, acceptable response time. All of a sudden, let's say 500 became 700 in production. That this can happen, right? Automatically, based on some conditions that I can decide, like CPU, memory, network, whatever condition, metric, any metric I can capture. If I see that if any contention is there on the CPU or memory, based on any condition, I would auto scale the number of servers. That will make sure that I'm not losing on the performance. Even if I'm increasing the load, my user load is increasing in production, automatically my servers are getting increased, auto scaling, both scale out and scale in. I'm not compromising on the performance, right? So these are the very important features that make Kubernetes reliable, highly available, fault tolerant. These are all the features is packed in Kubernetes, right? So before we talk about Kubernetes, right, so we need to understand what is Kubernetes. And before understanding Kubernetes, we need to understand what is container orchestration engine, right? So it all starts from microservices. Nowadays, all the deployments, we are no longer developing monolithic application, right? We have moved away from a lot of developments. You guys must be testing from performance background or some other background. You guys would be testing mostly on the API part. Microservices, we're talking about more nowadays. We're talking about containers nowadays, right? So we need something called container engine to create containers. Okay, so let me talk about few things on the container, then I'll come to Kubernetes and I'll demonstrate using one of the popular container orchestration engine. I'll show you in the Google Cloud Compute engine. Okay, in GCP, I'll show you how to create cluster and all those things. Okay. Those are the we'll discuss that things today. Okay, so coming to this particular microservices, it all starts from microservices. Back, like say 20 years back or even 10 years back, most of the developments were happening around monolithic applications. Monolithic applications. What does that mean? Let's say you have a 3-tier application: web server, app server, database server. Okay, let's see this: web server, app server, database server. All your business logic in the case of, I'm talking about in the case of monolithic application. Okay. All your business logic are deployed as a single entity, tightly coupled as a single entity we used to develop. So let's say if I have 5 modules, M1, M2, M3, M4, M5, whatever, let's say 5 modules. I'm packaging as a one one single unit. Basically, you're talking about one jar file. And with all the jar files, in that one jar file, I have all these 5 modules. That is called monolithic applications, tightly coupled. We are calling the functions, whatever the functions we are writing. Let's say for this particular module, I'm writing F1 to F20 functions. For this particular module, I'm typing F21 to F40. Let's say functions I'm writing. I'm calling the functions anywhere and everywhere. The functions are being called because it's one jar file. Let's say, understand one Eclipse project in Eclipse IDE. Just imagine one project and you have multiple packages and you have multiple classes in that, and you're calling the functions anywhere and everywhere across all the packages. So those kind of structure are monolithic applications. You have lot of code deployed as a single unit, right? See, that's how it all development was happening. It's still a lot of companies are doing it, but nowadays we have understood that disadvantages of this kind of monolithic applications. Mostly we have understood the importance what microservices bring to the table, right? In the case of this kind of applications, one of the disadvantages that even if one module is not working or one of the functions, the problem is one of the functions, it can bring the entire application down. It can bring the entire application down, and you need to deploy in a big compute. You need a big compute, high compute machine, application server, and that's how you can deploy this jar file and you can run that much big code, heavy code, right? And even if one failure can bring the entire application down. And that's why we are moving from monolithic to microservices. And what are we doing? We are breaking these modules as a separate and independent entity, right? That's how we are making it independent. What are we changing in the case of monolithic, from monolithic to microservices? What are we changing? We are making, let's say this is the application server. I am making it separate. All the modules, I'm deploying it separate, first of all. I am not calling the functions across these modules. I am basically exposing the RESTful endpoint. I'm using API. I'm exposing the RESTful endpoint. Let's say if these two modules need to talk, right, with each other. So I will expose RESTful endpoint. I will call this API and I'll get the information. But at the end, what I'm achieving? High availability in one way. Because if they say this one of the module is not working, let's say or having some issues with one of the functions, it's having some issues, it's not going to directly impact other modules. That's the biggest advantage of microservices. Other advantage of microservices is that you can develop these microservices in Python. It's technological independence it provides. Since I'm calling RESTful endpoint, I'm not calling the function directly. These microservices need not be developed in the same technology, right? This microservice can be developed in Python. This could be developed in Node.js. This could be developed in Go language. This could be developed in normal Java, Spring Boot. Because at the end, I'm not calling the functions. I don't have to have the same syntax. I am exposing the RESTful, I'm creating the RESTful endpoint and I'm calling it if I need to get some information from other modules. I can scale independently. In the case of monolithic, let's say if I'm running a performance test and I found that one of the transaction is having CPU constraint. Subhangi, my screen is visible. Subhangi, guys, please confirm if my screen is visible. Subhangi is saying my screen is not visible. Please confirm. Yes? My screen visible, I'm audible?
Yes, it is visible.
Okay. Subhangi,
Yes,
please
yes.
check the connectivity from your end. Okay. Thank you. So in the case of monolithic applications, let's say if we have issue with one, let's say I'm running a performance test, right? Let's say I found issue with one of the transactions. And when I looked into the issue, I found that CPU is the contention, this particular transaction. I have to increase the entire application server stack just because of one particular module or one particular transaction in that module. I cannot separately scale up that particular module. But that is possible in the case of microservices. If M2 has an issue, right? If M2 need more resource, more CPU, I can give more CPU to M2 because I'm deploying it separately in a different node. All are different nodes. The requirement, I can make it separate. I don't need to be fit everything on the same server. Like we call it, right? All size fit, right? Nothing like that. I can customize my different modules as per my requirement in the case of microservices. And this microservices, containers, Kubernetes gel very much together. Right? And that's why microservices are the best. Microservices architecture itself, it provides high availability. The way microservices are designed, forget about multiple nodes and forget about those things. Microservices as an architecture provides high availability as compared to monolithic application. The way it is designed, the way the code is separate and independent, it is giving you high availability first of all, right? And then where we deploy these microservices, guys? We deploy these modules on the servers, directly on the server, right? The best way to deploy this microservice is on the containers. Containers. What is containers? First of all, we need to understand that. What is containers? Again, if you talk about when the software development started, right? We used to there used to be a big physical server. Big physical server. When I say, consider a high vCPU and high RAM, some sort of physical server, and we used to deploy a tiny little application, few KBs or few MBs application. That's all we did back in 1980s. That's all we did when the software development started. Then what we did, we moved into virtualization. There was a technological virtualization. We understood that, see, we are wasting a lot of resource here, right? No doubt about it. We are wasting a lot of resource here. Then a technology came virtualization, right? And then what we did, we used the same physical server and installed something called virtualization software, like hypervisor, or we have VMware. We have a lot of virtualization software is there. We installed that and we created VMs. The idea of VMs, when the software development started, the idea was not there of VMs, how to create the VMs. We should directly deploy the softwares, some tiny little software, few KBs, MBs application onto the physical server. We did not know. To get started with, it was good achievement that we were able to deploy something. But later we realized it's a wastage of resources. So much high, 100 vCPU, 100 GB RAM, let's say 100 vCPU, 400 GB RAM, and we are installing something KBs or MBs application, right? It's wastage. So we after the introduction of this virtualization concept, we created VMs and we could deploy multiple applications. In the same physical server, we created multiple VMs and we can deploy multiple applications. Now we're talking about containerization. On one VM now, what are we doing? We are installing something called container engine. In one VM, this VM already has an operating system. We are installing something called container engine, like Docker. Container engine, like Docker. And when I install Docker, I can create multiple containers. And I can deploy these microservices. I can deploy these microservices here. Basically, what I'm talking about, to sum it up, let's say the difference between VMs and containers, if I have to just sum it up, what I'm telling you, that let's say if you have a 3-tier application, basically, so you need 3 VMs: web server, app server, database server. Let's say that you need 3 VM1, VM2, VM3. If you switch to the container concept, in one VM itself, I can run 3 containers. In one VM itself, I can run 3 containers: container 1, container 2, container 3. In one container could be my web server, another container could be my app server, another container could be my database server. Again, what are we achieving here, guys? With VMs, virtualization, and containers, what are we achieving? Very important thing. What are we achieving? What are we doing here? efficient utilization of the resource. That's what we are doing. Cost is at the center of everything. We realize that even if when we install web server or application server or database server on one VM, we are not fully utilizing its capacity. Some 20%, 30% we are using the capacity. It was found we are not using the VM to its full capacity. So why not to use VM to its full capacity? Let's use VM to its full capacity. Create multiple containers in one VM. And when this VM is completely fully utilized, then if you need more VMs, create more VMs and create more containers. Go with VM2, create more containers. C1, C2, C3. This will give you high availability also. If you have two containers of the same type deployed in two VMs, that will give you high availability also. Even if one container is down, you have other container to take care. Guys, I hope I'm making sense to most of you. Are we good, guys? Any question? Okay, I don't know about your background, guys. I'm just talking about a lot of things. I hope it makes sense.
Yes, Roshan.
Yeah. Any question you guys have before I talk about Kubernetes? Okay. Please, you can just mention your yes, no, any question. You can use the chat option if you don't like to unmute yourself. Okay, sounds good. Silence, I take, and I'm in a positive way. You must be nodding your head. I cannot see that. Okay, good, Srinivas. See, this is what the containers offer. Perfect, good, DS. See, this is what containers offer, right? So it's not about creating containers. See, to create container, what we need container engine, like Docker. We could create containers and I can deploy microservices. In this container, I deployed M1, M2, M3, I deployed. M1, M2, M3, I deployed. Multiple microservices, I deployed. Good. But I need more capability to achieve high availability, fault tolerance, reliability. Containers will not guarantee that. Containers are good technology, good to have. They are optimizing the cost by making sure that my resources nodes are fully utilized. That's good. But container engine by itself is not promising fault tolerance or high availability or reliability, right? Who offers that? Something called container orchestration engine. Container orchestration engine. Orchestration. When I use the word orchestration, the COE has a lot of features. COE has a lot of features. Okay, let me talk about take you to one of the slide. Okay. See, COE, when it comes to COE, right? See, the only difference between container engine and container orchestration engine. Container engine means Docker. Okay. Understand, there are other container engines as well, like we have Podman, we have Rocket. Okay. We have a lot of container engines, but Docker is the most popular container engine. Back in 2015, okay, back in 2015, Docker Inc. is the company name. Okay, Docker Inc. Docker Inc. the company name. They introduced this technology called Docker container engine. They introduced the word that they have something called Docker. They have something called container engine. You can install on a VM and you can create containers. Back in 2015, they introduced the word. Okay, Google was listening to it. Okay, Google let them release this Docker. It was a good thing. It was released. Docker Inc. released this Docker. Okay, Google was listening to it, and Google announced they are using a technology, similar technology from last 1 decade. They did not release this to world in the public, but back in 2015, they trimmed down one, they call it Borg, okay? They are using these tools called Borg. They trimmed down Borg and they released something called Kubernetes. And they did, it's an open source, and they donated this to CNCF, Cloud Native Cloud Foundation. So Kubernetes is COE, Docker is CE, Container Engine. Kubernetes is COE. Back in 2015, it all happened. It's not that old, some 7 years, right? So what is orchestration? What is different between Docker and Kubernetes? What is different between Container Engine and Container Orchestration Engine? We need to understand that, right? Before we understand Kubernetes, we need to understand what does orchestration mean. So when I say orchestration, if you check the literal meaning, wiki meaning of orchestration, it means automation, automates deployment, scaling, managing containerized applications. Automated. Automatics, it will deploy, scale, everything automated. So Container Orchestration Engine Kubernetes offers a lot of features which Container Engine could not. That's the main difference here, right? So if I talk about the COE feature, Container Orchestration feature, look at these features which makes Kubernetes Engine highly reliable in production systems, and why companies are preferring to deploy a Kubernetes cluster to manage their application to achieve high availability, high fault tolerance, high availability. That is the one of the reasons, because of these COE features. Clustering. You may have multiple microservices. You may have other different requirements. M1, let's say you have 5 microservices, M1, M2, M3, M4, M5. M1 needs to deploy on a particular nodes, N1. M2 needs to deploy on a particular node, N2, N3, N4, N4. It can take care of the clustering. It's not like all the microservices would go to the same node. You can configure it, different nodes. As per the requirement, you can cluster differently. As per the requirement. You can schedule it. You can schedule this. You can create cluster. You can create N1, N2, 5 clusters. You can have it. You can have multiple nodes of what I'm talking about. So you can have multiple nodes of N1, and you can deploy your microservices. You can create a cluster separately for each microservices. You can schedule it. Automatic scalability can be done. If more users come in, these microservices can be scaled up automatically. You need to give some conditions like auto scaling, how we have. You can scale it. Production, everything would be automatically done. Automatically it will be done. You don't need to do it manually. Let's say you can put on the CPU utilization. Let's say you are using 5 containers of M1, let's say that. 5 containers. You can mention that if average CPU utilization of all those 5 containers goes beyond 60%, create 2 more containers. It will do it automatically. It can be scalability, automatically it can be done. We have called, in Kubernetes, we have something called HPA, horizontal pod autoscaler, and cluster autoscaler. We have these 2 concepts, HPA and cluster autoscaler. HPA and cluster autoscaler. Cluster autoscaler, you can do this. Load balance. If you have 10 pods or containers, in Kubernetes world, we call it pods. We don't call it containers. Basically, one pod will have 1 container. This is pod, this is container. Usually, this is the 99% of the case. This is the scenario. So in Kubernetes world, we don't call it container. We call basically pod. Pod is like an encapsulation around the container. So let's say if you have 10 pods of one microservice.
Sorry, I'm interrupting.
Yeah.
Hello?
Yeah.
Could you please come again? Could you please explain it again, like pod and container? So there is some confusion.
What? Can you exactly ask what is the confusion? Where is the confusion? So that I can
like if someone asks, right, that what is pod and what is container?
Okay. Okay. In Docker world, right? In Docker world, we use the word container. Okay. But when it comes to Kubernetes world, right, we call pods pod. Basically, one container usually means one pod. Means pod is like an encapsulation around the container. That's what simple definition. Okay. So when I say container or pod, consider the same thing. So whatever I have told it for container holds good for same thing for pod as well. Okay. That's what simple. Keep it simple for now. Okay.
Yes, sir. So HPA is relevant for like Kubernetes, and CA is for Docker, correct?
Nothing like that. Okay. HPA stands for horizontal pod autoscaler. Hot pod autoscaler. Everything that I'm talking about Kubernetes only. CA is the cluster autoscaler.
Okay.
What is HPA? To increase the number of pods, and then CA to increase the number of nodes. This means increase the number of pods. This means increase the number of nodes. See, when you auto scale, you would require more containers, more pods, right? First of all, but when you don't have nodes, where the pods would get created? Correct. You need first.
Correct.
You need first nodes, then only in that node, means in that VM, pods would get created. So both. So these are the features of whatever I'm showing you in this diagram, in this slide. It's all about Kubernetes. Nothing, I'm not talking about Docker here. We moved on from Docker. Docker was only to understand containers. Why we need containers? To deploy microservices. Now we got containers, but we need COE. We need these features to achieve high availability, better reliability, fault tolerant application. That's why we're talking about COE. So one step ahead, right, from the container. COE also use container engine to create containers, but COE has these features as well. That gives you high availability, better performance, better fault tolerance, high reliability. Right? Making sense, everyone? Guys, please confirm. All good? Shall we proceed?
Sure. Yeah.
Okay, good. Anil, all good?
Yes, sir.
Okay, good. Okay, so now load balancing. See, these are the features of COE, Container Orchestration Engines, Kubernetes. Load balancing. When you have multiple pods of same microservices, you need to load balance also. Okay, I'll take up the questions later. You guys are writing a lot of things. I cannot look into the chat if I'll get distracted. I'll look at the end. Okay. So I'm gonna just close my chat window for now. Okay, let's focus this. So if I have multiple pods of the same microservices, I need to load balance. If I don't load balance, then it's not going to be what good. Why do I have multiple pods first then? Right? So it will give you the load balancing also. Scalability also it will do. Right? I talked about HPA and cluster autoscaler. Fault tolerance. In Kubernetes, we have an object called replica set. Replica set would make sure that, let's say in the replica set you mentioned that you need 5 pods always up and running, because you know that 5 pods are required to support 100 users load. And let's say one of the pod goes down for any region, XYZ region, Replica set would make sure you have 5 pods always up and running. Isn't that great, guys? Think this through. You are required to run 5 pods to support 100 users. For any region, 1 pod goes down, and automatically the new pod got created. Automatically, yeah, you get time to troubleshoot why it got down, why it went down, and you can take the dump and take the heap dump, thread dump, and you can analyze what is the root cause. You can check the logs. All those things can be done, but performance you did not degrade the performance because you always have 5 pods running. So fault tolerance, and you can do automated deployment. Automated deployment means, let's say, when you use container, in the container you use image version. Let's say I used image version v1. I'm using right now, all good. Now I have a new version v2 of the image. I want to deploy this. Now tell me one thing. If you want to deploy a new version, do you want to experience downtime? Yes or no? First tell me that. Do you want to experience downtime?
No.
No, we don't want to experience downtime. This is possible in COE. That is possible. You can change the version without downtime. That is what deployment would give you. So all these features of COE makes Kubernetes highly reliable, highly available, fault tolerant designing architecture. Kubernetes can help you design such an architecture because of all these features, right? Okay. So we have spent quite 40 to 45 minutes. Any question till this point of time? Guys, please unmute yourself. Any question?
What is mean clustering?
As I told you, right, clustering, in the first place, you have multiple microservices, right? You have M1, M2, M3, you have multiple microservices, different requirements. You need multiple nodes. Let's say you want to deploy 5 nodes of this. For N2, you need 3 nodes of this. You can create cluster for that. You can have a separate node, basically, for this particular microservice. You can create a cluster, separate cluster for M1, M2, different microservices.
Okay.
That's what the clustering means. Okay. Any question, guys?
Rasan, one.
Yeah, go ahead.
Hi, Rasan. This is Anik. One question I have.
Go ahead. Yeah.
So basically, like fault tolerance means like if any, I mean, suppose out of 5 nodes, if any node goes down,
Pods.
then in that case, automatically.
Yeah, you can use.
Yeah, sorry. If any.
Use the fault tolerance word. Fault tolerance definition is the performance should not degrade. Performance should not degrade, even if component failure is happening. That's what the definition of fault tolerance. Okay. Yeah.
Okay. Then in that case, like if any pod goes down out of 5, then suddenly it's up to the COE to bring one new pod to maintain that.
That particular in the COE in Kubernetes, that particular object is called replica set. Replica set is responsible to give you fault tolerance.
So replica set is a part of Kubernetes orchestration, right?
Cluster. Yes, that's right. Okay, I'll do one thing, right? I'll show you a Kubernetes cluster. What I have done, I have created this cluster in Google Compute Engine. Okay, in GCP, what I have done, I have created. Look at this. So this is the GCP. Okay, what I did, I just went to the Kubernetes engine. Okay, so this Kubernetes is an open source. First of all, understand this Kubernetes is an open source. Okay, all the cloud service providers, they have used the open source and created a service around that. AWS, they have created a service called EKS, Elastic Kubernetes Service. Azure, they call it AKS, Azure Kubernetes Service. GCP, which I'm showing you right now, they created a service called GKE, Google Kubernetes Engine. It is that popular. Kubernetes is that popular that all the major cloud service providers, they have created a service, managed service. You don't need to worry about creating cluster. If you have to go it manually, do it manually using Kubedium. It's a very long process. You can install Kubernetes manually. It's a very long process. But you use any one of these managed cloud service providers service, it's going to be very easy to create the cluster. Okay. So what is Kubernetes cluster, first of all, right? We need to understand that. So if you talk about the architecture, right, of the cluster, this is what a Kubernetes cluster would look like. You have a master node. You have a master node, first of all. You have a master node and you have cluster. In the cluster, you have multiple nodes, node 1, node 2, node 3. What the node would have? Pods. And the pods would have the containers. This is the pod would have the container. Basically, one pod usually has one container, but multiple container pod is also possibility. We'll talk about it some other time. But usually 99% of the case, one pod will have one container. But you can have multi-container pod also. In multi-container pod, there could be only one main container and other would be the helper containers. H1, H2. This is the main container, C1. And the other two containers would be the helper container, data pullers, pushers, or proxies, those things. Okay. So this is a basic architecture of Kubernetes. You have a master node and multiple worker nodes. And in the worker nodes, you will deploy the microservices. You will create pods and you will deploy microservices. And all those features that we talked about, clustering, scheduling, fault tolerance, all these features will be there in this Kubernetes, which will make your production system highly reliable, highly available, fault tolerant. Any question on this? Okay, we have a lot of things, okay? In master node, we have a lot of components. I'm not going into it, but just in the high level, that's it. Okay. Go
Hi,
ahead.
Roshan.
Hi.
Hi, Srini here.
Yeah,
is that same mechanism of the blockchain technology? Is it in this Kubernetes?
what
Like storing the nodes of multiple blocks kind of thing it is showing. So is the same mechanism of blockchain? The Kubernetes will follow?
No. Kubernetes is a COE. Okay, it's a kind of a deployment thing.
Okay.
It's a deployment.
Oh, okay.
Talking about nodes here, right? And talking about microservices. Guys, please mute yourself.
Yeah. Okay, I got it.
Sure.
And is the Kubernetes only will implement in the production system or other than environment as well?
I'm not able to hear you.
You got my point, right?
No, I could not hear you.
No, the Kubernetes will implement only the production systems.
What?
Or other environments also we can.
End of the day, what is the main goal? Production. Production. Okay, please mute yourself first. I'm echoing. First, please. Thank you. Yeah, I'll answer your question. See, when I say production system, what do you mean by only production system? What is other systems? Help me understand. What is other system? Obviously, you will test in performance environment. When you say Kubernetes is only for production system, what is other system you have? Answer this first. Ask this question first.
Yeah, we have other environments like pre-production environments,
so obviously
like
you will test
performance engineering environment or UAT environment, right? So generally the performance testing will be do in PE environment, right? So the performance testing will not do in production environment, right?
See, point is simple. if you want to deploy Kubernetes in production, you will have to test in first PE environment, right? How it is working.
Sorry. Yeah, that's why I'm asking. So we need to. So what is the use of suppose we are implementing in PE environment and as well as we are implementing in production environment, right?
Okay.
So what is the differences? I understand.
Srini, why do you have QA environment? Why don't you directly have production environment? What is the purpose of QA environment?
Yeah, for a better quality. Before going to the production.
Before going for production, to test. Correct. Same thing. Whether what is right, what is the right number of nodes, which node, what configuration, where to set HPA, on what percentage to set HPA, cluster autoscaler. You have to test this. Once you test it,
yeah. So yeah, I understand your point, Roshan. So my point is so we are generally doing in performance engineering environment, right? So whatever the test we have done. So what the Kubernetes will do, like we have already CI/CD environment, right? So there are Jenkins or other open source kind of thing.
okay,
So what Kubernetes will achieve
one by one.
other than this? So that is the main important.
One by one. So you are telling Jenkins and Kubernetes is the same thing?
No, deployments you are saying, right? So deployment purpose you are saying, right? The Kubernetes you said.
See, Kubernetes is offering you so many things. Jenkins.
Oh, okay.
Why are you confusing yourself? Jenkins has a different purpose. Jenkins is a CI tool. Continuous integration tool. Why are you confusing with Kubernetes? Why are you comparing Jenkins with Kubernetes?
No, I'm just asking, like this open source, right? This is also open source and that is also
Jmeter is also open source.
So yeah, that's right. So what is the futures of Kubernetes is most important. Like only you are saying only when the organization is moving to the cloud, then the Kubernetes will comes, or in on-premises also they will use Kubernetes. So you said like the service only it will be provided. Okay. So on-premises also they will use, or only the cloud whenever the organization is moving to the cloud.
On-premise or cloud infrastructure remains the same.
Oh, okay. Got it. Yeah.
Either you're using cloud or using on-premise. End of the day, infrastructure is.
Yeah, we are using both. Yeah, we are using the both. So that's why whether the Kubernetes will come to the picture in cloud or in a.
Understand.
Okay.
Wherever you are going.
Yeah, got it.
Yeah. Okay, guys. I'm gonna throw this.
I'm sorry taking the time. Sorry, Roshan. So I'll just clarify on this. Yeah. Thank you for your time.
Okay. See, so this is the Kubernetes architecture. What I have done, I have used GKE here, Google Kubernetes Engine, to create the cluster here. I have showed you a similar architecture here, the master node and the worker nodes. In the managed cluster, when I create the managed cluster, let's say I'm using GKE here, Google Kubernetes Engine here, right? In this cluster, you only get to see the worker nodes. You don't get to see the master node because it's a managed service, right? If you go inside this cluster, you can deploy things like different YAMLs. You talk about YAMLs so that in the YAMLs you will have different Kubernetes objects like pods, replica set, as I talked about, different services deployment. You will have different YAML files, right? And you will deploy this in this Kubernetes engine, right? So this is the cluster I'm showing you. If on GKE in the GCP console, similar thing can be done if I log into the AWS console. We have a similar thing called EKS, right? Let me just click here. I'm going to just log into AWS console and show you that they are also using, they have something called EKS. How I showed you for GKE, some other time I'll show you how to deploy other containers, microservices and all. I need to deploy the YAML files. I will connect to this cluster some other time and I will show you. But I'm just showing you that in AWS, we have something called EKS, this service. This is such a popular service that all the major cloud service providers, they have created a service around this, right? I can create the cluster here. I can create the similar to that, what I have done in the GKE, in the GCP console. I can do the same thing in AWS, and I can create the cluster. When I say cluster, I talk about this master node and worker nodes, and then I will make use of YAML files to deploy microservices. And then we need to set HPA, cluster autoscaler. We have to do all those things. We need to talk about Kubernetes is a vast concept, but it's very effective in production. That was my end of this agenda of this, to make you guys understand what Kubernetes brings to the table, right? That's all from my side, guys. Just to let you know that if you're looking for a full-fledged course, right, I'm coming up with a course next week. Okay, one of my batch is getting started on cloud performance engineering and on SRE. Okay, and we are covering all those things, whatever we just talked about in the Kubernetes. Let me just show you both. Let me talk about SRE right now. So if I just show you the SRE syllabus, which with Isha, I'm coming up with this particular full-fledged training where I talk about cloud, a lot of things. Okay, it's a full-fledged 50 hours of training where we give self-paced training for self-paced video for Python, Java, and performance engineering as well. Java performance engineering, along with we cover cloud in AWS. We cover a lot of things from basics. What is SRE, all those terms, technologies that we just talked about. What is monolithic microservices, Docker, Kubernetes, right? Both in EKS and both in GCP, both we talked about in both the cluster, talk about different pods, different objects that we have, HPA, cluster autoscaler, replica set, everything in detail that we talk about, and how to gaining resiliency in AWS, different services that we have. Observability, very important monitoring part, performance engineering, some eliminating toil and automation using Terraform and Ansible, and Jenkins, right? And last but now, and we are giving this self-scripting, self-paced core Java and Python self-paced recording as well. Okay, so I would like you can we have this demo on next Tuesday and Wednesday, right? You can go over these two courses that I'm coming up with. Next week the demo would be done, so you can go over if you're interested. Let me share the link, and you can join me next week for more details, guys. Okay, I just shared the link, guys. If you're interested, please check on these things, and you can contact this number to get to join the demo. Okay, and Mr. Kumar can help you. Mr. Kumar Gupta can help you enroll to the demo sessions. Any question, guys, I can help you with. We are done for the day. Okay, we are done with the agenda. Any questions you have, feel free to ask.
Do you have any separate roles for this Kubernetes apart from this performance engineering, or it's a part of a performance engineering?
I could not understand. Separate course are you talking about?
No, I'm talking about like, is there any separate role in organizations for this Kubernetes specialist?
No, either
or it's a part of a performance engineering.
Performance engineering or DevOps. Only. Yeah, or SRE.
Oh, okay.
Kubernetes would be mostly be handled by performance engineering or DevOps or SRE professionals. depends on the organization. Mostly these two people. Yeah. Performance engineering also important, right? So depends. All depends.
Okay.
What is the way organization is being structured? Performance engineering expert or DevOps or SRE engineer can be asked to work on these things. Even support engineers, they need to work on Kubernetes because everything is in Kubernetes, right? And they need to also learn Kubernetes. Even support engineers, L1 engineers. So everyone, release engineers, everyone, all across. If the entire infrastructure in Kubernetes, everyone all across the organization, you have to learn. Right? That's how it is. But mostly the troubleshooting part would come to performance engineering guys, yeah, and SRE guys. DevOps guy would deploy things, but troubleshooting part would be taken care by performance engineers and SREs. Okay.
Yeah, got it.
Sure. Okay, guys. Thank you so much. I hope you learned something in this 1 hour. Hope to see you soon. Thank you so much.